Hello everyone. Today we will discuss about oscillation. So what is an oscillation? Oscillation is a movement in to and fro movement. So what does it mean? If we see with an example, if we see a swing, so swing will be like this and it will go in this direction and then comes back and go in this direction, and again it will go in the same direction. But here in the mean position, this will be the mean position from where it gets started. This will be the mean position, or it is an equilibrium position. So the action takes place, or the movement takes place in a periodic time while coming in its mean position every time is called oscillation. So it is a to and fro movement which comes in the mean position every time when it passes through it, and again it goes back to the same direction. So this motion is known as oscillation, and it will be in a periodic time. What does it mean? It means it will move in a certain period of time from this position number 1 to position number 2. This will be the position number 1, this will be the position number 2, and let's say the number 3 is the position number of mean time, mean position. This is the mean position. And how can we define it? Oscillation is a movement or a variation in a particular or a periodic time, like back and forth motion and motion. Example, if we say example, this is a swing is an example of oscillation. Examples if we take, or a pendulum is an example of oscillation. So these are some examples of oscillation in a periodic time. But now what questions come in our mind? Periodic time is also comes like this. If we see examples of planets revolve in a particular direction, and here if we say sun and this is earth, so it keeps going on and coming back to the same position every year, right? In 365 days it complete its revolution. But this is not complete. We cannot call it a oscillation. It is a movement in a periodic motion. It is a one revolution in the mean time, in a particular time. So all periodic motion cannot be. So here we can write, or we can result it, or we can mention it. Periodic time. In periodic time, all movements, not exactly oscillations, all movements happens are not oscillations, but at the same time all oscillations happens in only periodic time. So what does it mean? Oscillations directly depend on the periodic time, but all the movements which happen in a particular time or a periodic time are not called as oscillation. They can be revolution. Oscillation means it is a particular movement which comes in to and fro direction, or a to and fro motion, or back and forth also it's a motion. So now what are the types of the oscillations? If we see how many types of oscillations, so basically if we see types of oscillations, so there are mainly three types of oscillations. Three types. So what are those three types? One is free, second is damped, and third one is forced. So now we will discuss these three oscillations, these three types of oscillation one by one. So number one is free oscillation. So what does it mean? When a body vibrates with its own frequency. Here free oscillation means when a body vibrates in its own frequency, with its own frequency, is known as free oscillations. What does also means that free oscillation has a constant amplitude and a particular period without any external force. So here main thing which we have to focus in free oscillation is there is no external force is applied. The oscillations are happening. Oscillation happens by its own frequency. So when we are not applying any external force and the oscillation happens by the object's own frequency is known as free oscillations. So here we can see the example, sound produced by a tuning fork in a short distance, or notes of musical instrument. So when we let's say example of guitars. So if we see notes of musical movements, notes of musical movements in musical instruments. So here what we can see that in the notes, when we apply when the notes are giving, so notes of a musical instrument is an example of free oscillation. Now second comes what is damped oscillation. So it is an oscillation referred to that degrades over a specific period of time. What does it mean? Like a swing. If we apply a force, swing goes in a particular direction and comes back its mean position, but over a period of time with friction, force and with the pressure of air, it comes on a particular mean position. It stops basically, and which comes on a equilibrium position. What we can say that here it's an equilibrium position or mean position. So when it degrades its energy automatically by friction and environment or air force, you can say that force by air, then it is known as damped oscillation. Swinging a pendulum also is an example of damped oscillation. Now third one comes is forced oscillation. Forced oscillation, as the name indicates, when we apply a force on an object. What does it mean? Oscillations in which the body oscillates with a frequency other than its natural frequency under the influence of external periodic force. So what does it mean? When we keep applying the force externally on an object like a swing, we can take example again. If we keep applying the force in a periodic time, it will going on and on with its own frequency and the external force which we applied on it. So these type of oscillation is an example of forced oscillation. Now if we see what are the parameters we have used here in these all free, damped and forced oscillations are new. What are the new terms came? One is basically we use frequency, second is period, So first what comes in our mind is frequency by which it moves. Second is time period or period, you can say that. Period or time period. Why? Because of that, because the oscillation happens only in periodic time. And the third one is amplitude. Amplitude also affect the oscillation. How it affects, we will learn one by one. So now we will see how these parameter affects oscillations. So now first we will see period of oscillation. Period of oscillation. If we discuss about period of oscillation, what comes in our mind? Period means time, basically. Period means time. So it is denoted by T, capital T. So this is the symbol of period of oscillation or a periodic period. What does it mean? When you call a time as a period? If we take a pendulum or a swing as an example, it will go, when we apply the force, it will go in a particular direction, comes in the mean position and goes in that direction, and then again back in that direction. So this full cycle going from position 1 to 2 and coming back from position 2 to 1, this is a one cycle completed. So this full cycle is known as a period. There's one cycle which completed, any pendulum or a swing in a periodic time is known as a cycle. And how we can define a period or a period of oscillation? It is the time taken by that object, by that swing or a pendulum or any other object which we are taking as an example, the time taken for one complete oscillation from 1 to 2 and 2 to 1. This will be the one complete oscillation is called as period. So as time, we know that its unit is seconds. This is the unit which we use usually for time. And the formula, if mathematically we go to see the formula, so this will be the formula. Time 2 pi. Pi is a constant. Length is basically the objects or the swing or pendulum or any object which we are taking. So length is length of the object which we are taking, and g is acceleration due to gravity. And it will also act as a force on the object, by which the object can comes in the mean position, in the equilibrium position. So this is the period of oscillation. Now second is frequency. Now we will see what is oscillation frequency. So the number of cycles, as I already told you, the one complete cycle will be from point 1 to 2 and 2 to 1. This will be the complete one cycle. So the number of cycles that happens in per second is known as the frequency. So the number of cycles which happens per second. Or cycles can also be denoted as oscillations, because these are oscillations only. Second is called frequency. This is known as frequency. And as frequency, how we can denote it? It is denoted by F. And what is the unit of frequency is Hertz. This is the unit of frequency. And if we compare with the time, so frequency will be 1 by T. Why it is? Because it is inversely proportional to T. When the frequency is higher, so time period will be smaller, and the time period is higher, then the frequency is smaller. So these are inversely proportional to each other. Now third comes is oscillation amplitude. So what does it mean? It means that we already took the swing example, and when we see in the swing example it coming in the mean position or the equilibrium position, right? So in the mean position or the equilibrium position, the maximum displacement from the position, mean position, from this side to this side, the maximum displacement happens is known as the amplitude. So this will be, if we take the example here, so the displacement happened from 1 point to 2 points. So this will be the amplitude. This in one direction and this will in other direction. So the maximum displacement from the mean position, is known as amplitude. So how we can denote amplitude? As A will be the symbol of the amplitude, oscillation amplitude, and what is the unit of amplitude is meter. Here the unit of amplitude is meter. Now these are the three parameters: amplitude, frequency, and period of time or period of oscillation is the which quantify the oscillations basically. Now comes in oscillation. If we see, oscillation is also a motion basically. Oscillations are motion itself, right? So what kind of motion how we can define this motion, this to and fro motion or back and forth motion, how we can define it? So the motion of a body is said to be oscillatory motion if it moves in to and fro direction from a fixed position in a regular interval of time, and the fixed position about which the body oscillates is called the mean position and the equilibrium position, we already discussed. And now comes periodic motion. Periodic motion, it is a process or a phenomena by which it repeats, the object repeats itself at a regular interval of time is known as periodic motion. But when we see, here comes some basic points or some basic terms: equilibrium position, second one is restoring force, and third one is stable equilibrium. If we see, ideally there will be no equilibrium position, because all the time there are force present in the environment, in the atmosphere where we live. So there will be no ideally equilibrium position. We just assume this will be the equilibrium position, like in a swing or in a pendulum we assume as a mean position. Stable also, it will not be a stable equilibrium, because again there are lots of forces directly or indirectly acting on a swing. So there will be no stable equilibrium position in the swing. There will be always force acting on it, like acceleration due to gravity, air forces, friction forces, and there are a lot of forces also which are acting on the swing or on all the objects which are present in the environment. So these are the basic terms which we have to clarify in our mind, that there will be no ideal situation of equilibrium position. And restoring force, we will discuss it later. Before that discussing, we should discuss what is simple harmonic motion. Now after oscillation, it comes as simple harmonic motion. So basically it is a special type of periodic oscillatory motion. This is also a oscillatory motion and which is also periodically, but it is a special type of periodic motion. Why it is special? Because it oscillates on a straight line. If we take an example, let me take new paper, sorry. Yeah. If we take an example here for oscillation or simple harmonic oscillation, it goes in a straight line. It goes in a straight line. So here the first you can say these are the qualities. So the particle oscillate in a straight line. Oscillation in straight line. Second one is acceleration of the particle is always directed towards the fixed position of a line. So if we fix one position of the point, one point of the line, this may be, this we can say example a line, and point number 1 is fixed on its end. So the acceleration of the particle, the acceleration happening in the of the particle is always directed towards the acceleration directed towards the fixed point of the line, and the magnitude of the acceleration is proportional to the displacement of the particle from the fixed point. If we see acceleration happening, what is acceleration? Acceleration means the moment, the frequency by which it is moving. So the frequency coming, then the second term. If the frequency terms is coming, then magnitude also come. So magnitude, what does it mean? In which direction, particular direction, the displacement is happening. Displacement means the cycle, the maximum displacement about the mean position. So what here we can say that the displacement. So if we mathematically, if we see, if A is acceleration, it is directly proportional to minus x. Why minus x? Let's say x is the mean position. X is the position where the point the object is fixed, and then it going in the oscillation going in a straight direction. When the acceleration comes back towards it, then it will be the negative direction because it is fixed. It is not moving in a particular time. There is a fixed position and it is moving and coming back. Moving and coming back like this. So this acceleration or this displacement coming from this point 2 to point 1, it will be in opposite direction. That's why we take minus x. So if we remove proportionality sign, then acceleration is equal to minus omega x. Omega is the angular velocity or basically proportionality sign. Now comes in the last paper, last discussion, I told you one point or one word is restoring force. What is a restoring force? So the force which is responsible to maintaining the simple harmonic motion. The force which maintain the simple harmonic motion is known as restoring force. So basically, if we take this example, the force which is maintaining the full action what is going on in the experiment or in the on the object is known as restoring force. Now comes simple harmonic motion is classified. How we can classify this? So it is classified. So here comes simple harmonic motion. Simple harmonic motion can be classified into two types. So one is linear simple harmonic motion and second one is angular simple harmonic motion. So what is linear harmonic motion? So when a particle moves in to and fro direction as a fixed point called equilibrium position along with a straight line is known as, so again it will be in a fixed point. This is the fixed point, and to and fro motion like this in a particular interval of time along a straight line, is known as linear simple harmonic motion. If we take an example, spring mass system will be the example of linear harmonic motion. So it is the mass is attached with a spring, and when we apply a force, so one end is fixed and the other end is moving in a particular direction and coming back. So the oscillation happens in to and fro direction, but the one point is fixed. So this is the perfect example of linear harmonic motion. Now comes to what is angular harmonic motion. So when a system oscillates angular along with respect to a fixed axis, then its motion is angular simple harmonic motion. So here it is fixed with a point, but here in angular motion it is fixed with a axis like x-axis or y-axis. This is y-axis. So if we take the example of angular simple harmonic motion, it is the oscillation which are fixed along with one axis. It could be x, it could be y. It depends what you are taking, what objects you are taking, and in which direction you want to move that object. So these are the two classification of simple harmonic motion. One is linear simple harmonic motion and other one is angular harmonic motion. Phases or phase of simple harmonic oscillations. So what does a phase mean? The concept of phase is a way of comparing two oscillations at the same time, which are occurring at the same time, and one has its maximum excursion at a different time than the other. It is not compulsory. The one is in, if we take an example of swing, so one is in its maximum position, let's say 1 and 2, and if we say another example 3 and 4, so it doesn't mean that one is as its maximum will be the second one is also at its maximum. How does we define a phase? We can define a phase. It is a comparison of two oscillations. These oscillations which are happening at the same time, but does not necessary here both comes in the same direction or at the same maximum excursion at the same time. Maybe it could be or it could not be. So the phase is a way of quantify that difference between the oscillation. Here what the difference is coming between A and B position. So the difference A position and B position in oscillation difference is phase. Basically, this what does it mean? So the difference between these phase is basically phase is a way by which we can quantify the difference between these two oscillations.